Okay, so I'm going to look at today dividing complex numbers. So the first example I have is calculate 15 plus 10i divided by 5. Okay, so similarly with fractions, this one here we can divide it across. So I'm just going to separate it up first of all. So it's just going to be 15 divided by 5. So it's going to be the real divided by 5 plus 10i divided by 5. Okay, so we know that 15 divided by 5 will give me 3. 10 divided by 5 will give me plus 2i, and that's the answer for this one. Okay, so if we see it being divided by a real number, we can just break it down like so. I'm going to run through another example here. So it's 2 plus 11i all over 2 plus I. Okay, so now we're actually dividing a complex number by another complex number. Okay, so up here it was straightforward because I was dividing by a real, so I was able to just divide across. But because I'm dividing by a complex number, it's a little bit more complicated. So what you have to do is you have to multiply the top and the bottom by the conjugate of the bottom here. Okay, so it's always the conjugate of the bottom. Okay, so I'm going to rewrite this then. It's 2 plus 11i multiplied by 2 minus I, because that's the conjugate of the bottom. Remember, to get my conjugate, you looked at it yesterday, you just change the imaginary sign. Okay, so that becomes minus all over 2 plus I bracket 2 minus I. Okay, so by multiplying across by the conjugate, we are going to eliminate the imaginary number down below. Okay, so what I'm going to do, first of all, we have two brackets being multiplied by one another, so I need to split my brackets. So it's first term, which is 2, times everything in my second bracket, 2 minus I. My second term, which is plus 11i, times everything in my second bracket, 2 minus I. All over, and I'm going to do the exact same thing for the bottom line. So my first term, which is 2, times everything in my second bracket, 2 minus I. My second term, which is plus I, times everything in my second bracket, 2 minus I. 2 times 2 will give me 4. 2 times minus I will give me minus 2i. 11i times 2 will give me plus 22i. And 11i times minus I will give me minus 11i squared. All over 2 times 2 will give me 4. 2 times minus I will give me minus 2i. I times 2 will give me plus 2i. Plus I times minus I will give me minus I squared. Okay, now what I have to do is I'm going to just tidy up the top. So I have 4 minus 2i plus 22i will give me plus 20i minus 11. We know that I squared is minus 1, so I'm going to just fill in minus 1 all over. Right, 4 minus 2i plus 2i, that's cancelled. Then I have minus I squared, so minus, and I know that I squared is minus 1, so I fill in minus 1. Now I have 4 plus 20i, minus by minus will give me a plus 11, all over 4 minus by minus will give me plus 1. Right. Okay, the next thing that I need to do is I need to just simplify this down further. So 4 plus 11 will give me 15 plus 20i all over 5. This can be broken down again. So as we did with our first example up here, because I'm dividing across by a real, I'm able to just break this down. So this will be 15 over 5 plus 20i over 5. So 15 divided by 5 will give me 3. And 20i divided by 5 will give me plus 4i. And that's my final answer. The next question I have here is write 15 over I in the form p plus qi, where p, q are an element of the rational numbers and I squared is equal to minus 1. Okay, alright, so similar to what I had in the previous example, I'm now dividing by a complex number. When I'm dividing by a complex number, to get rid of that, I need to multiply top and bottom by the conjugate of just the bottom. So I need to find out, okay, what is my conjugate of the bottom. Okay, if I was to write this in the form a plus bi, it would be 0 plus I. The conjugate then of that, so remember my conjugate has the line over the z, is equal to 0 minus I. So now I have this, okay, so it's 15 over I, multiply top and bottom by the conjugate, by minus I, by minus I. 15 times minus I will give me minus 15I, all over I times minus I will give me minus I squared. So I now have minus 15I all over minus I squared is minus 1, so I fill in for that. So I have minus 15I all over minus by minus will give me plus 1. So my final answer then is just going to be minus 15I. Okay, and that's your final answer. Oh wait, they asked me to leave it in the form P plus QI. So in the form P plus QI, I have A plus BI. So this is going to give me 0 minus 15I is the final answer here. I'm going to run through a few more examples. Okay, so this is question 2, part I. Okay, so it's 5 plus 5I all over 1 plus 2I. So the first thing I need to do is I need to get my conjugate of the bottom one. Okay, so my conjugate of the bottom one is going to give me 1 minus 2I. I then multiply both top and below by the conjugate here. So I have 5 plus 5I multiplied by my conjugate 1 minus 2I all over 1 plus 2I times my conjugate 1 minus 2I. Okay, so when I'm multiplying brackets out like this, I need to split them first of all. So I take my first term, which is 5, times everything in my second bracket 1 minus 2I. I take my second term, which is plus 5I, times everything in my second bracket 1 minus 2I, all over. Okay, so it's going to be my first term, which is 1, times everything in my second bracket, my second term, which is plus 2I, times everything in my second bracket. 5 times 1 will give me 5. Okay, 5 times minus 2I will give me minus 10I. 5I times 1 will give me plus 5I. Plus 5I times minus 2I will give me minus 10I squared. All over, I need to now multiply out my bottom line. Okay, so I have 1 times 1 will give me 1. 1 times minus 2I will give me minus 2I. 2I times 1 will give me plus 2I. Plus by minus will give me minus. 2I times minus 2I will give me minus 4I squared. Okay, so I need to tidy all this up. So I have 5 minus 10I plus 5I will give me minus 5I. Minus 10. I squared we know is minus 1, so I'm going to fill in for my minus 1. All over my 1 minus 2I plus 2I, that's gone. Minus 4I squared, and filling in again is minus 1. So I now have 5 minus 5I. Minus by minus will give me plus 10. All over my 1 minus by minus will give me plus 4. And that's equal to that. So 5 plus 10 will give me 15 minus 5I all over 5. Okay, and we can break this down further. Okay, so every time I have something like this, a real number on the bottom, and I want to divide it, I separate them. So I have 15 over 5 minus 5I over 5, because both of these numbers are being divided by 5. So 15 divided by 5 will give me 3, minus 5I divided by 5 will give me minus I, and that's the final answer for that one. I'll run through one more example. Okay, so this is question 7. So it says if z is equal to 1 minus 3I, write the conjugate of z over z in the form a plus bi. Right, so my conjugate of z here is going to be 1 plus 3I, and z is equal to 1 minus 3I. Okay, I'm now going to fill in. So wherever I have my conjugate, that's what I'm writing here, is 1 plus 3I. all over my z is 1 minus 3i. Okay, so now you can recognize what I have here is basically a division of a complex number. So I am dividing by a complex number, so the first thing I need to do is I need to get the conjugate of the bottom. Okay, so the conjugate of my bottom is 1 plus 3i. I need to multiply top and below by my 1 plus 3i. So it's 1 plus 3i times 1 plus 3i all over my 1 minus 3i times my 1 minus 3i. Okay, the first thing I need to do, because I have brackets, that means it's been multiplied, I need to split them. So it's the first term, which is 1, times everything in my second bracket, 1 plus 3i. My second term, which is plus 3i, times everything in my second bracket, 1 plus 3i. All over my first term, which is 1, times everything in my second bracket, 1 minus 3i. My second term, which is minus 3i, times everything in my second bracket, 1 minus 3i. 1 times 1 will give me 1. 1 times 3i will give me plus 3i. Plus 3i times 1 will give me plus 3i. Plus 3i times plus 3i will give me plus 9i squared, all over 1 times 1 will give me 1. 1 times minus 3i will give me minus 3i. Minus 3i times 1 will give me minus 3i. Oh, this should be, multiplied by 1 plus 3i. Okay, so this is 1 bracket 1 minus 3i minus 3i times 1 plus. Okay. Okay, so 1 times 1 will give me 1. 1 times plus 3i will give me plus 3i. Minus 3i times 1 will give me minus 3i. Minus by plus will give me minus 9i squared. Okay, right, now I'm just going to tidy up my top line. So I'm going to have 1 plus 3i plus 3i will give me 6i. Plus 9i squared is minus 1, so I'm filling in for that. All over plus 3i minus 3i, they cancel. 1 minus 9 bracket I squared is minus 1. Okay, so I have now 1 plus 6i minus 9 all over my 1 plus 9. Okay, and this then gives me, so 1 take away 9 is minus 8 plus 6i all over 10, which I can break down. So 2 will go into all of these numbers here. So minus 8 divided by 2 will give me minus 4, plus 6 divided by 2 will give me 3i, and 10 divided by 2 will give me 5. Okay, and if I'm asked to put in the form a plus bi, it will be minus 4 over 5 plus 3 over 5i, and that's the final answer. Okay, so the final example I'm going to run through is question 8. So let z1 equal to minus 1 plus 5i and z2 equal to 2 plus 3i. I'm asked to investigate where the conjugate of z1 divided by z2 is equal to the conjugate of z1 divided by the conjugate of z2. Okay, so the first thing I'm going to do is I'm going to divide z1 by z2. So I'm going to fill in, so z1 over z2 is equal to, so I know my z1 is minus 1 plus 5i, all over my z2 I'm filling in for is 2 plus 3i. Okay, I'm now dividing by a complex number, so that means I need to multiply the top and the bottom by the conjugate of this here. So the conjugate of the bottom is 2 minus 3i. Okay, so when I rewrite that, I'm going to have minus 1 plus 5i times my conjugate of the bottom, which is 2 minus 3i, all over 2 plus 3i times the conjugate of this, which is 2 minus 3i. Okay, so I need to now split my brackets. So it's my first term minus 1 times everything in my second bracket, 2 minus 3i. My second term, which is plus 5i, times everything in my second bracket, all over my first term, which is 2, times everything in my second bracket, 2 minus 3i, my second term, which is plus 3i, times everything in my second bracket, 2 minus 3i. Okay, so minus 1 times 2 will give me minus 2. Minus 1 times minus 3i will give me plus 3i. 5i times 2 will give me plus 10i. 5i times minus 3i will give me minus 15i squared. All over 2 times 2 will give me 4. 2 times minus 3i will give me minus 6i. 3i times 2 will give me plus 6i. Plus by minus will give me minus 9i squared. Okay, so then tidying up, I have minus 2. Minus 2, 3i plus 10i will give me plus 13i. Minus 15, I squared is minus 1. All over, okay? Minus 6i plus 6i, that's gone there, cancelled. 4 minus 9, I squared is minus 1, so I'm filling in for minus 1. And I now have minus 2 plus 13i, minus by minus will give me plus 15, all over my 4 plus 9. So minus 2 plus 15 is going to give me 13 plus 13i, all over 4 plus 9 is going to give me 13. I can break this down again. So I have 13 over 13 plus 13i over 13. And my final answer then is going to be 1 plus I. Okay, but I'm asked for the conjugate. So the original question has my conjugate of this being divided. Okay, so I need to investigate whether it's equal to this over here. So my conjugate of this is actually going to be 1 minus I. Okay, so this is my answer that I'm hoping that later on we find out that they are equal. Okay, so the right hand side is now what I'm trying to prove. Okay, so I have already figured out over here that when I worked out my Z1 over Z2, I got my 1 plus I, and now I need to get my conjugate of that, which is going to be 1 minus I. Okay, so hopefully we find over here that we get the answer 1 minus I. Okay, right, so the conjugate of Z1 is going to be minus 1 minus 5i, all over the conjugate of Z2 is 2 minus 3i. Okay, I'm dividing by a complex number, so that means I need to multiply the top and the bottom by the conjugate of the bottom number. Okay, so this is going to be times 2 plus 3i times 2 plus 3i. Right, when I'm multiplying out here, so it's minus 1 minus 5i bracket 2 plus 3i, all over my 2 minus 3i times 2 plus 3i. Okay, alright, the first thing I need to do is I need to multiply out my brackets. So I take the first term, which is minus 1 times everything in my second bracket, 2 plus 3i. My second term, which is minus 5i, times everything in my second bracket, 2 plus 3i, all over my first term, which is 2, times everything in my second bracket, 2 plus 3i. My second term, which is minus 3i, times everything in my second bracket. Okay, and now I need to multiply them out. So minus 1 times 2 will give me minus 2. Minus 1 times 3i will give me minus 3i. Minus 5i times 2 will give me minus 10i. And then minus 5i times plus 3i will give me minus 15i squared. All over my 2 times 2 will give me 4. 2 times 3 will give me plus 6i. Minus 3i times 2 will give me minus 6i. Minus by plus will give me minus 9i squared. Now just tidying up the top line. So minus 2. Minus 3i minus 10i will give me minus 13i. Minus 15. I squared is minus 1. All over my plus 6i minus 6i cancels, and I have 4 minus 9, I squared is going to give me minus 1. Okay, so it's minus 2 minus 13i, minus 15 by minus 1 will give me plus 15, all over my 4 minus by minus will give me plus 9. Okay, and then I have minus 2 plus 15 will give me 13i, minus 13i, all over 4 plus 9 will give me 13. I can break this down. Sorry, this should just be 13. Okay, and I have 13 over 13 minus 13i over 13. And I'll get 1 minus I. And we wanted to prove that that was equal to 1 minus I, and it is the case. So that was true for question 8.